It gives me great pleasure to introduce our next speaker. So, Roger Piqueras Jover is a renowned researcher in the areas of LTE and 5G mobile network and wireless protocol security. He's a longtime user, supporter, and advocate of open source software for wireless security research. Roger leads the Android connectivity security team, focusing on hardening bare metal connectivity firmware and protecting Android devices from false base station attacks. Prior to his work at Google, Roger was a senior security architect at Bloomberg, and before that, a principal member of the technical staff with the AT&T Security Research Center, heading its cellular network security and privacy area. As a leading mobile and wireless security researcher, Roger has provided expert advice to industry, academic, and government groups in matters of telco security. He served as the advisory board chair to CCI in 5G security.
Thank you. How do you say this goes? Forward and backwards?
Exactly.
Okay. Hi, everyone. I was just telling Paul and others that it's been a while since I gave a talk. I took advantage of the pandemic to stop traveling and whatnot. But as Paul said, I've been a long time user and a huge fan of this tool. And also DC is kind of close for me. So anyway, I decided to come here to talk with you. I'm going to be talking about maybe not a super technical topic, but a topic that is very near and dear to my heart, which is the impact that open source in general has had in cellular network security. First of all, usual disclaimer, everything that I will discuss here is my personal opinion and doesn't really represent anything that my employer thinks or does. With that behind, so again, yes, I wanted to tell you how I ended up here career-wise, and also, I guess, like here right now where I'm standing. And this is pretty much a combination of cellular network security and open source. It's been a journey. I think I started using, I'll talk about it in a minute, but there was something before srsLTE called OpenLTE. And I started using that in 2013, I think it was. And anyways, from there, it's been just a very exciting journey. For the ones who don't know me, anyway, my name is Roger. My job and being a dad to kids keep me very busy. The ones who know me know that I'm obsessed with soccer and my team, FC Barcelona. That's where I'm from originally. And I lead a team in Android that works in security. We focus particularly in hardening Android devices against false base stations, and also on hardening the software that runs inside of the cellular baseband in Android smartphones. I've been doing cellular security for many, many years. And anyways, when I'm not busy with my kids, my family, or my job, I like music and soccer. And anyways, I have a couple of accomplishments that I'm very proud of up there in the slide. So the first thing I'm going to do is I'm going to start talking about a bit of a retrospective of cellular network security and what happened over the years. And you'll see that at some point there was an interesting change in trend that I'll double click on when we get to that. So some of you might be familiar on this, some of you might not, but security has been evolving in cellular for throughout the generations. 2G, if you don't know this, 2G is fairly insecure for today's standards. It wasn't, arguably it was when it was launched because there's no mutual authentication. The verifies that you are who you claim to be, but the phone never verifies that the network is indeed a real network. But also, very importantly, the encryption or the ciphers used in 2G are long obsolete. Today you can break, well, today, like 10 years ago, 15 years ago, you could break them. In 3G, things improved, and there was mutual authentication. For some reason, don't ask me why, because I don't know. There's barely no security research in 3G. So, security got better, but like there's not much insight beyond that. And then LTE, ciphering got stronger. There's still mutual authentication, but it was broken in a number of ways. And anyways, there's a bunch of researchers that did really exciting work, and we'll talk more about this later. And then in 5G, there's a lot of buzz, and that is more secure. It is more secure, and if you could have your phone strictly only on 5G SA and nothing else, with super encryption always enabled, things would be much better. But for example, the SUP encryption is an optional feature, unfortunately, so it's not widely used. This is, I've wanted to redo this timeline for a long time, but I'm a combination of busy and lazy and I haven't. But anyways, you can see here a few key events on like the timeline of cellular network security that I put in here. So you can see at the very left, GSM was first deployed in Finland in like, what is that, in December 91. Things were broken around December 2003. And then anyways, one key thing that we'll talk about later is that like the x-axis, and again, this figure is terrible, but if you see it on the x-axis, the scale changes quite significantly. LTE, the standards were published in 2008, deployments were in 2012. I was working for a big carrier back then. I remember that we were all talking about LTE and deploying it and whatnot. And the first attacks in early 2016. And 5G, and we'll talk more about this, there was a lot of security issues being found before it even was launched. So let's talk about a few of these. In 2004, there was the first quite relevant paper. Elad Barkan and a few others essentially demonstrate how you could crack or break the ciphering in 2G. Nothing bad, it's just that the 2G cipher was designed like probably late 80s, and by that time was pretty obsolete. And that was essentially the first time that there was a publication or a finding that with an actual system attack against a cellular protocol, these demonstrated how you could break the cipher, brute force the cipher in 2G and extract the session key, which is what is used between the network and the device to encrypt. And once you have the session key, by the way, you can impersonate either side of the communication. But one key thing is that you could do that, but nobody could really do that. It was a theoretical paper because there was no means for doing that. There was labs in places with very expensive equipment that could do 2G fancy things, but like for researchers out there and academic groups, there was no such thing, and that was missing. So then in 2010, Carsten Knoll, if you haven't heard about Carsten Knoll, you should Google him. He's done a lot of super interesting work. Carsten Knoll and his team, they essentially closed that gap, and using software radios and an open source implementation of 2G, they demonstrated this live. I will never forget this talk. They, at the end of the talk, they called each other. Funny because I think that either one phone number was seen on the screen, so they started getting text messages from people in the audience. But anyways, they called each other, and after they call each other, they hang up, and then they just do some magic on their laptop and the radio, and then they replay the audio. So they intercepted the phone call, and they broke the cipher, and they just decrypted the audio right there, and it was pretty impressive. That was at about the time, so give some time reference on my story. That was about the time that I was starting my job at that big carrier working on cellular security. That was, as far as I know, the very first publicly known system attack against the cellular protocol that was published. And we have to fast forward quite a bit to 2015, 2016. That's when I started, anyways, doing things, I guess. Well, I had been doing work in this area for many years, but in between that job and another job, I took some time off to like redo some experiments and publish things that I hadn't been able to publish before. And then myself and some of the folks in Berlin, we published at about the same time some papers that like essentially the gist was that there was a lot of things that were assumed were not possible in LTE that were actually possible, like things like IMSI catching. You could easily DOS devices. You could downgrade the connection to 2G. And once you downgrade to 2G, then everything that is happening in 2G could happen in your connection. Anyways, those were the first, at least I'm aware of, papers or talks or presentations that presented system attacks against, in this case, LTE protocols. Then fast forward to 2018, 2019 is when like things started going out of control. I remember having a lot of fun those years because there was then a lot of academic teams working in this area and finding really, really cool things. This is one of my favorite papers then, breaking LTE on layer 2. They do all sorts of like cool things in this paper. They reuse a thing that I came up on my paper in 2016 to kind of identify users in a cell, not by the TIMSI or the IMSI, but by their NTI, which is a physical layer ID that used to never change. I just found out that apparently it changes more frequently than I thought now. Anyways, and long story short, things that they were able to do here was there was a poor implementation of AES encrypting user plane traffic, and they would alter DNS responses such that when a phone was browsing something and getting the DNS response of where to go, the attacker could redirect the user or the phone to an attacker-controlled server, which was pretty cool. And all because they were using AES, but like it was wrongly configured and reusing, I forgot what it was, but it was just like the mode of operation was not very good or not very well thought. As I said earlier, with 5G, it was very interesting because before the networks were deployed, academics and researchers were already finding issues. Back at that time, it became a thing that kept me entertained. So I was tracking all these publications. I wrote kind of, I think, a blog or something. It's here. Yeah, it was a blog down here, talking about all these papers. But it was very interesting. To me, that was a clear signal that this was a trendy or popular topic. Now you had researchers that were looking, if you find an issue on a cellular network that is deployed globally everywhere, like that, has a lot of value. But researchers here were just finding things and looking for things at a protocol that was not even deployed, and that was quite interesting. Some findings on the cipher, on the AKA, which is the algorithm they use to authenticate and derive keys and whatnot. So there was a lot of interesting findings. I myself, I don't even know if I listed me here, but I wrote a paper back then with somebody from Virginia Tech actually, where we were arguing that yeah, there you go, there it is. That anyways, there was things from LTE that looked awfully similar in 5G, and that making us a bit nervous. Eventually, on the last talk I gave before the pandemic in 2020, actually I demonstrated how those issues were actually real. Then starting in 2019, there was another kind of like shift, a trend. That is that this research topic was not only popular or trendy in academia and with academics, but it was also trendy because it was, you would publish a paper and you would have Wired and Gadget and all these like, groups writing stories about you. So that was I think that was very good because it gave a lot of visibility to those researchers that would usually have, would have published papers in like, Usenix or like Auckland and whatnot. And that's always a good thing. But like here, they would get all this like press coverage, and that always helps. And I think that like when you're a PhD student, like getting your name on like a big news story on like Engadget or something like that, it must be something very exciting. So that was an exciting trend that I thought it was, I had never seen that before. And it was interesting. It was, at some point I was more effective at tracking like new papers and new things by like reading the news than like, and Paul told me that there was a trick that you can put on Google Scholar. You can put keywords like srsRAN, security, IMSI catcher, things like that. And that's how I do it now. Now you guys also keep that thing with like research papers, but that one doesn't send me email alerts. Or can it send me email alerts? No? Okay, feature requests. So I do it with, Google Scholar, you put a search with keywords and it sends you an email when somebody publishes a paper in that topic. It works pretty well. Yeah, a little bit of like spam sometimes, but it works pretty well. Okay, so let's come back here. This is my super ugly figure that someday I promise I'll redo. But essentially, you can see that on the left, on the, let's say, 2G era and starting of LTE era, there was a few things happening over a large span of time. And then roughly at like, what's that, between 2011, 2013, 14, some of those years that like lots of things started to happen every year, not even every year. Like it was insane. There was like, at some point there was like so many papers, so many articles, so many things that I just didn't have time. I used to keep like this reading, I still have it, my reading list of papers I wanted to read. And I was like literally months behind on that because there was so much coming up. And so what happened here? Like we can look at it in numbers. Like with 2G, it took 18 years from the deployment to the first demonstrated attacks. In LTE, it was 8 years from the standards to first demonstrated vulnerabilities, and 3 years only from deployment to first attacks. And then in 5G, there was a bunch of things already found before the standard was even alive. So what happened? Like my question is, and like that's kind of like why I'm here and what I want to talk about is what happened between 2012 and 2015 that changed this so much. And then what happened was this, like open source. OpenLTE, the first commit was December 31st, 2011. That's the first tool that I used. It was not very stable, but for the first time, you could set up a false base station using software radio on LTE, and it would do everything for you. And like IMSI catching became like trivial. You don't have to do IMSI catching. If you have a false base station that doesn't know your SIM and it's never seen that subscriber, part of the protocol, eventually they figure it out and the subscriber eventually sends the IMSI in the clear. So there you go. You just run OpenLTE out of the box and it's an IMSI catcher. You just have to add an fprintf, and I'll get to that later. srsLTE, please keep me honest here. I think like the first commit was like 2014. I'll talk more about it later, but that was kind of like the game changer of the game changer because things were much easier and it was much more stable than OpenLTE. An operator interface, I'll be transparent here. I've only used it a couple of times. Back then in when it started, I didn't get much goodness out of it. Maybe to the credit of srsLTE, everything was so easy with srsLTE that essentially I stick to it. So if anybody is a user, I would like to hear from their experiences, but I haven't used it much myself. Hardware also played a role. Like back then with 2G, you could have equipment that would do these things, but it was very expensive. 2G, like your bandwidth, your bit rate is low enough that you could do things with software radio, with like a small computer. But LTE, you're talking, at least back then when I was doing this, it was 10 megahertz and like 50.4 megabits per second. I remember when I started doing this type of research, not any Linux laptop would work. You needed a pretty beefy laptop to run OpenLTE or to run srsLTE. Now, pretty much any laptop, if you have a decent laptop, it will run. So software radio was the other game changer. I'm pretty sure most of you have used one, if not all of these ones here. To me, this was the other game changer. Like with such a cheap radio, being able to do the things you were able to. And out of the blue, you could, with open source tools and a radio that is like, I mean, the most expensive one here is like $900. You need to add this thing for like stability. So it's like $1,400, maybe more. And there's some here that are $500, $600. So with like a $1,000 radio and open source, you could have an LTE base station in your lab, which was pretty cool. And that was definitely a big game changer that also helped a lot in this area. I remember, I don't know if you're familiar with this one, but the one at top right, that's the USRP Mini. When that one came out, I was a huge fan because it was like the regular one, but mini. And then I could have like, things on my laptop bag. I don't carry my laptop bag anymore, but I used to carry it and I would go around everywhere I would go, like conferences and whatnot, I would carry one of these, and it would be running LTE, it would be running like a Bluetooth sniffer, like a bunch of things. And anyways, it was interesting. Once I went to Mobile World Congress with this thing, and like my machine crashed because it ran out of disk space because I was only sniffing control traffic and things that are a regular sniffer would get, but there was so much stuff. Like there's thousands of people in that place. But anyways, it's very cool because it made experiments very portable. I'm very out of date of how this is now. That you used to need a pretty beefy one to get srsLTE, srsRAN to work. I don't know what's the status, but one thing I know is that they have very good documentation, and I'm sure that somewhere in the documentation it tells you what hardware is recommended. So in summary, what changed between the early years and when things started happening was that open source tools matured. There was a lot of excellent work from academia, like feeding each other. I always like to highlight this one. I'm pretty sure that this was a big deal, and like it helped. The fact that all this area of research became so popular that it ended up being in technical media and technology media and whatnot, and software radios. So yeah, when this happened, it wouldn't be strange to find this type of like headlines in these areas. So the way I see it, cellular network security, at least what has happened for the last 7-8 years, would never have happened before without open source. And that's why maybe not cellular network security, but I personally love open source software. It's allowed me to do lots of really cool things that I wouldn't have been able to do otherwise. So I was talking earlier about SRS, they kept changing the name at some point. It was very confusing. I still, in my head, call it SRS LTE, although it's now 5G. So SRS LTE, Open LTE, and Open Air Interface, I was calling those the game changers. But like in all fairness, like the two heroes, the very first ones were OpenBTS and Osmocom BB. I don't know if anybody remembers either one. OpenBTS was open source implementation of a 2G base station. It's still out there. You can use it. I was acquired and like things happen, but anyway, it's still out there. It's still open source. And if you Google, you can find blogs of people that tell you how to build an IMSI catcher in like 2 minutes with like just a Linux box. And the good thing is that 2G is very narrow bandwidth and very low bit rate. So have you guys tried running OpenBTS on a Raspberry Pi? I'm pretty sure you can run it in a Raspberry Pi, one of the good ones. So the laptop in the back and antenna, so you could have your own. Anyways, there used to be a lot of those in DEF CON back then. People carrying Raspberry Pis and 2G base stations in their bag. And Osmocom BB was an implementation of the stack, but on the device. So you could make changes and then flash it on an old device, one of those like feature phones, and then once, like talking about like stories from the past, once I went with one in a laptop bag as well, walking around one of these big hacking conferences, collecting metrics that like to see how much activity that is suspicious I would see, and there's like summary, there's a lot. So anyways, these were the two tools that really changed things. I wrote an article in, when was that? 2016, talking about this, talking about how everything changed with OpenBTS and Osmocom BB, and how open source had such a tremendous impact on cellular mobile security research, and talking about that particular talk from Carsten Knoll and Sylvain, where they did that thing. They called each other, they internet the cipher, and then they played the audio live. Like for me, that was like a game changer. Like open source, that talk, that was the first talk that I saw in our conference, like in cellular security, hacking things in cellular security, and from that moment on, like the impact has been tremendous. So as I was talking about earlier, OpenBTS, open source implementation of the 2G works pretty well. It's back then it used to not be super stable, but now it's super stable. I'll show you something that they did with OpenBTS in a moment, but it's very stable, open source, works pretty well. You can probably run it on a Raspberry Pi, although I've never tried. Lots of interesting findings have been achieved using this tool. Lots of papers back then on 2G. That was an interesting trend. When people were already starting to break LTE, you would still see people working on 2G security, which I remember thinking like, oh, come on, 2G, like nobody cares. But like, arguably, like we should care. There's still 2G in many places in the world is one of the most widespread cellular standards, and it's important that we continue working in security in that area. One thing I'll mention about Android, I'm barely mentioning anything about Android in this talk, is that Android introduced in Android 12, which was 2 years ago, the first option that you can disable at the modem level 2G for security. And that's the feature that prevents you from all these types of things. And one of the reasons why we can't just disable, if we wanted, we could disable 2G for all Android devices. We could ship the phones with 2G set to off, but we cannot do that. There's a risk of connectivity impact. So there's a lot of 2G still out there, and we have to be mindful of that. I think right now it will be a bit old news working on 2G security research, but people continued banging on 2G for many years while people were already working on LTE. I was mentioning earlier, like how stable OpenBTS is. It's so stable that it's being used for commercial deployments. These are some islands that are off Canada. I think they are like you know, part of French territory. But there's other examples, but this is one that I know about. This is a place, this is a real place where there's like real people, and like the cellular service is like, you know, it's 2G only, and it's based on like software radios. The software radio somewhere out there with like antennas, and what that's running is OpenBTS, and they provide service for like a few thousand users. People. So this speaks about, I mean, well, now people have like software-based deployments for a lot of things, and it works very well. But back then, when I saw this news, that for the first time, I was very impressed. Like, it was the first time that I saw somebody running a commercial deployment using software radios and open source. So pretty cool. And this that I know, there's two more. You can try to find them. But yeah, it's very interesting. OpenBTS used in a bunch of places. I think that's the reason why at some point it became owned by a company or something like that. But anyways, OpenBTS. Osmocom BB was an implementation of the baseband, or not the baseband, of the stack on the phone. And so OpenBTS, the base station, this is the UE side. And also super convenient for research. It's been used for a couple of projects I'm a big fan of. Actually, this is one of my favorite projects. So when the paging protocol in cellular essentially has a racing condition. Is that if you know how cellular works, when somebody is what's happening is that the network is going to page me on a number of towers in this area, depending on how big the tracking area is. And all of them are sending a paging saying like, hey, Roger, are you here? And then what happens is that the first UE anywhere in these towers that replies, yes, I'm here, is the one that wins the race. Another story is, well, they impersonate me, or like, you know, or like if you have my SIM and whatnot. But in 2G, this was broken. So essentially, these guys, what they did was combine these two things. They would win the race, and then they would break the cipher. And essentially, they would, you know, they would pick up calls for you. Somebody's calling you, and somebody else is picking up the call, which is not cool. But it was a really, really cool paper back then. So anyways, there was a lot of excellent 2G security research between 2009 and 2012 or so, and then is when OpenLTE happened. I always like to say that I probably would not be here career-wise if it wasn't for OpenLTE. There was a lot of things that I was experimenting with that was very hard to do, and now out of the blue with this tool, I could do it very, very easily. The first commit was in New Year's Eve 2011. I don't know what Ben was doing, but anyways, and it was abandoned in 2017. But then he pushed a major update on Valentine's Day 2021. And one thing I wanted to that I was mentioning earlier is that with OpenLTE, cellular research became very, very easy. Before OpenLTE, it was very hard to do IMSI catching experiments. You needed specific hardware, expensive hardware, things like that. With OpenLTE, it's literally just a single fprintf. Because if you have a phone with a SIM and you have an OpenLTE and the network has never seen that SIM, they will figure it out, part of the protocol. Eventually, you will try to attach with the IMSI. And then what you have to do is add an fprintf on where in the code where you're processing the attach request with an IMSI. And just print it, which is the very first line I added myself to srsLT. The first line of code I ever added to srsLT was, where's the attach request with IMSI? I found it, I added an fprintf. So anyways, I always like to thank Ben, who's the guy who created OpenLTE, because that was the tool that essentially changed everything for me. And then, again, you guys changed the name so many times. I still call it srsLT. So srsLT essentially changed things because OpenLTE was good, could do a lot of things, but it was a bit unstable. But srsLT essentially did everything, and they kept pushing updates and including new things. Keep me honest here as well. First commit 2014. And one thing that I like a lot about srsRAN is that they have very good documentation. There's a very strong community, a very strong mailing list. You ask a question, people answer. You never had that in OpenLTE. If you had an issue with OpenLTE, just go figure it out. Or if you know what, Ben, like maybe you can ask the question directly. But in srsLTE, you have an entire community behind it. That's what makes this tool, very, very exciting. Beyond just the great tool that it is, like all the community behind it makes it really, really helpful. And I always like to say that with srsLTE, and I'm going to keep calling it srsLTE my whole life, despite how many times they change the name. Cybersecurity research went from like a starting field, like an early field, to something that was mainstream, because now it was fairly easy for an academic to do lots and lots of really interesting things. It speaks volumes to how many things you can do. The fact that they have a section for research on their page and it keeps growing. I don't even know. There should be a counter here just for fun. 300, yeah. So they keep track of everybody who does research with srs LTE, and there's a lot of these papers. I don't know what percentage. That would be actually interesting to know. But a lot of these papers here are things that have to do with security, IMSI catchers, protocol exploits, things like that. Even like in the field of baseband security, like you use SRS, or at least I use srsRAN, or srsLTE, whatever, to inject payloads into the baseband. If you find a bug and you want to exploit it, these tools are very helpful for that. And again, open air interface, as I said earlier, very transparently. I only used it a couple of times, a long time ago. It also released in 2014. And I know a lot of people who've used it very successfully. Myself, just used it a couple of times trying, but I've heard it's a very cool tool. And if anybody has used it extensively, I would like to hear about your experiences, because at some point I would like to give a talk where I actually talk about all the tools and not leave one where I feel, I'm bad because I'm not saying much about. So what's next? Well, what I think should be next, the one thing that I've been thinking a lot about is that a lot of these papers, a lot of these projects, a lot of these findings, like what researchers always do. And I understand. I was in their shoes. I was there myself. Like, breaking things is very cool, and it's important to break things because, for example, in software, it's important to break things because when you break something, then we can fix it. One thing that we do, again, another thing I'll say about Android is that we have a vulnerability rewards program that we put a lot of people behind and we put a lot of value on, because we believe a lot on the value of like researchers sending us bugs that we can then fix. So breaking is pretty good. If you're breaking and you're thinking of, for example, like going into an industry job eventually, breaking in academia, it works, but it's not very time effective. Like you should start thinking about like scaling how you break things, like fuzzing or automating things of what you're doing, because eventually just the things that we do manually, that I was doing manually when I was working in the area, are not going to be enough. But anyways, most of the papers that I've seen, I'm tempted to say all of them, are breaking things. I myself broke some things on LTE when I published those papers back then. But I think that it's important that we also start shifting to because the reason why some of these issues, now talking about cellular security, the reason why some of these issues occur is because of, in my opinion, somewhat not broken protocols, but like protocols that were not designed with the assumptions we have now for your threat model. And it's very hard to change things entirely. So from 3G, so 2G, there was no mutual authentication, but from 3G to 4G to 5G, the security model itself has barely changed. It's essentially the same thing. You have a SIM card and something on the network that there's a shared private identifier, the INV, SUPI, 5G, whatever. And then you have some key material, and you use that to establish trust and to establish a secure connection. But that hasn't changed at all any of the generations. And that's the problem. That's why you have mostly the same problems in 3G that you have in 4G and 5G. I don't know if anybody here works in like security of like, I don't know, like consumer devices or whatnot. But if they told us, Android, that we have to establish a secure, like establish trust for like a secure boot, for trusted boot, for anything that it's like between an Android device and backend, and we had to do it based on keys, like we would not even try. The problem is that the security model is very limited, because by definition, if you only share a set of secret keys, you're very limited in a lot of things. There's always going to be lots of messages. Eventually, you do an authentication kind of handshake that derives keys and whatnot, and from that moment on, you can trust it with a network that has a copy of the key that you have in your SIM. But until you reach that point, everything that comes before that is essentially, I call it implicit trust. Like the phone receives messages from the network that are not signed, are not nothing, they are plain text. You could be sending them with a radio and srsLTE a million times, and the phone believes it's coming from the real network, and vice versa. And that is a problem. And we've only scratched the surface. There's like so many bad things you can do probably with those messages. Now I'm also particularly concerned, usually for like an academic lab, you need to have the false base station and send things into the phone. But like, I always worry a lot about the country. What happens with srsRAN? Are you still maintaining that thing? srsRAN was, I didn't talk about it here, but that was like the thing that was like the game changer. And I thought, oh my God, it's going to be bad. So you know how there's bugs in software in phones, and you can send a packet and maybe you crash the baseband or something and the phone crashes, and okay, sure, whatever, like the baseband reboots and everything is good. Or like worst case scenario, there's a guy here who has a history in doing this, like you can execute code remotely on the baseband. That's like really bad, but it's just one phone. But with srsRAN, essentially you could do the same thing against the core network. And I thought like, oh my God, there must be so many bugs in like the MME or like things like that. So anyways, there's a lot of risk here. And I think that it's important that we start switching to fixing as opposed to breaking. How can we switch to fixing is hard. Than to fix things, and I know because I was there. And all the papers continue being primarily about breaking things. I personally I remember when I saw this a long time ago, I don't even know how I saw it. I think it came up using my query on like Google Scholar. But anyways, I remember you guys were working on a platform for like security based on open source. Like these are the type of things that are good. We need to come up with ways that we can help people fix things. We can help people try new things, try new protocols. How can we establish trust between a phone and the network in a way that is not dependent on like a pair of symmetric keys, which is essentially a terrible way of doing it. It's like on the internet, on my browser, when I go to gmail.com, like before I start talking with gmail.com, my browser already knows that is really Gmail. As long as you trust, like, the certificate and whatnot, there's like, there's some caveats there, but like, my browser, I know that I'm talking with like Google servers. Like why when I have a phone and I see a tower that claims to be like, I don't know, Vodafone, like my phone just trusts that it's Vodafone based on like literally an integer on a message that has no security. So anyways, these type of platforms, these types of things that make it easier for researchers are things that are very helpful. And then another thing that is important is we have to incentivize researchers to do fixing, and also incentivize the industry to do fixing. Nobody will fix anything. If you're a company and you have like so many things to do and you have limited budget and whatnot, like you will. There's lots of praise for security teams out there, but like if there's no strong incentive to fix one thing, you probably will fix something else first. So it's always helpful to give incentives to people to fix things. And one thing that I think is key here is transparency. There's a leader in my company that I admire a lot that says something like, transparency is the tide that raises all boats. Essentially, transparency is the way that you get all these things. Transparency is the way you get incentives. Transparency is the way you get people to find cool to work here, because if you work on something that fixes things, you're not going to end up on the cover of like one of these like sites or whatnot. But with transparency, you're giving visibility to things that you're doing, that you're fixing. For example, say that you had two given smartphones, and right now, if you take two smartphones and I tell you which one is protecting my privacy better, that's a pretty complex question. It depends on a lot of things, and maybe you can give an answer based on something that is publicly known. There are like all devices that the biometric is not hardware backed, so it could be not easily, but it could be tampered with. Like that would be less secure than a more modern smartphone where like the biometric is hardware backed. But like it's very hard to like answer the question out of these two phones, which one is protecting my security, my privacy better, and giving means or tools or ways to answer these questions, to compare these devices apples to apples and say, oh, like this one is better than the other one, that would be something a lot, and would not only incentivize doing more research in the area, but it would also incentivize the industry and whatnot to improve things. I have some examples here. Like there's not really an easy way to know this, but like is a way of knowing, is a device going to accept a null cipher connection? Like I didn't even talk about this, but like in cellular, the network can decide to not encrypt the connection, which is not a big deal for anything that is IP-based. If you have Android, for example, all IP-based traffic is always TLS protected, always. Like apps cannot opt out from that. But your, let's say, old school SMS and old school voice calls are only encrypted with the cipher the network provides. And the cipher, and the network is the one that picks the cipher. So it's not good if your connection is not ciphered. And with a false base station, you can easily set up like a cipher to be no cipher. So anyways, transparency is something that is important. It's missing today. We don't have good tools to do these things. I'm working with some teams in this area, and I'm interested in working more in this area, and I encourage others to work in this area. But I think this would be something where it would be very cool if we could have something like you get a phone, you put it in a Faraday cage, you hit go, and it generates you a report or something that compares it with another one. This is something that I've been working on a couple of years with the team, but I want to get more and more people working on this because there's other things that are not easy to do with this method. Like, for example, baseband security. How can I know whether the software running in this in the baseband of this phone is better than this other phone? So these are things that are hard to answer. These are very interesting research questions where you're not breaking anything, and I think that there should be more people working on this. But anyways, at this point, I've been talking for almost 38, 39 minutes. So I'm just going to say that I very much look forward to seeing what you guys and all the researchers out there are going to be doing for the next 5 years and more. And with that, thank you for having me. And if you have any questions, I'll take questions.
Thanks, Roger. I'm going to take advantage of having the microphone to ask the first question. So very often we get asked the question, aren't you making it easier for people to break things by putting the software out there? What's your response to that?
Yeah, that's a very good question. It's a tough question. You can ask the same question in different contexts. It's the same thing as I don't know when it was, a few years ago, there was a thing between Apple and the FBI because of a phone of somebody who had committed a horrendous crime. So you can ask the same question in different ways. By doing these things, aren't you making it easier for the bad guys? Yes, you are. But the bad guys, in many cases, many of you in this room, probably your bad guys are not a 22-year-old PhD student. You're worried about countries I'm not going to name or other companies and whatnot. Those adversaries can do these things, no problem. They already have probably srsRAN from 15 years ago. So I think that falling for this, thinking too much about this question is bad, because essentially what you're doing is you're making a disservice to PhD students who are helping, and you're not really giving any advantage to the bad guys. If anybody thinks that any of these is helping a nation state hack into anything in a way that they couldn't do before, I think, in my personal opinion, that they're very much wrong. It's the same thing as you can abstract this to walls. Why building walls? Bad guys are going to hide behind the walls. Well, we need walls because we need people to have shelter and whatnot. So it's a good question, and I can see how you guys get asked the question quite a lot. Nobody had asked me this question in the context of open source. I had it asked in the context of privacy and encryption and whatnot. But yeah, essentially, if you want to think about it, it's not easy to answer the question, not easy at all. Especially when you have kids, you start thinking about things a bit differently. But it's the same thing as encryption. Should we not have end-to-end encryption? Should we have everybody's traffic intercepted? Because then they will, you're essentially helping the bad guys. So it's the same thing. In this case, I think it's even easier. If your adversaries can do this and even more. What you will be doing is just making the life complicated for PhD students who are just doing really cool work that helps others. A good question and a tough one.
Yeah, I think that the vulnerabilities and exploits have always been there, and I see open source as switching on the light and just exposing it.
Yeah, exactly. Some of these things that we're finding, they've been there since of the protocol. We're just students are finding them and helping patch them, but the bad guys might have been in this for years and we didn't know.
Yeah, stop monopolizing the mic. Any questions?
I can just talk loud, it's okay.
Sure.
I actually have a follow-up to the prior question. So in my perspective, it's more eyes on the project will flush it out. Kind of going back to the transparency thing. So if you have transparency, you have more eyes on there. But can you talk to any unique attack vectors or any unique challenges that we should probably focus on in open source projects that may be unique to open source versus closed source?
Unique projects specific to open source?
Yeah, so like a unique attack vector that may be more suited to open source projects.
Yeah. Okay, I see. Let me know if this serves as an answer. Another thing, and that's like you can have the discussion in a completely different context, but the question of open source versus no open source. Like there's companies that are like, no, why am I going to like use open source? Like everybody can see the code I'm using and whatnot. Prefer to use my closed source tool. Again, like this is just like security by obscurity, which is like when you're in security, you know that these things don't work. The benefits of open source is that like you have open source software out there, and now everybody is essentially banging on it and finding bugs on it. If you use closed source, like say like network equipment and whatnot, the only ones that are like trying to find vulnerabilities are like the digital army of like certain countries and like others, but you don't get the benefit of like an entire community of people finding issues, including improving the software. So I am not an expert in the area, and I'm not much in tune of what's happening in this space, but I know that these guys are like that's what they do now. But I think that like the fact that networks are going soft networks. I mean, let me think if I'm going to say that. It's not that I would trust more, but I was mentioning earlier, like there must be bugs, software bugs in the MME, and now I can use srsUE. Well, I don't even know if it's maintained anymore, but I guess srsUE to inject payloads into the MME. Like if the MME is closed source, that's what I get very nervous, because there might be things there that like code that nobody has looked in like years. But if they were using an open source MME, I would feel a bit more comfortable because it's something that like others are looking at. Finding those issues. Does that serve?
It sounds like you're saying that if you don't have the verification that's happening on the open source tools, that may be an issue with the open source project. But that verification aspect is key. Like you mentioned, if it's a closed source tool, you don't actually see what's happening inside that closed box. But because you can verify it in the open source, you have more certainty in that protection. So if an open source solution doesn't have that verification process or community verifying it, that could be a particular attack vector.
Yeah, that's a good point. I guess that when people find issues, I remember reading a paper that was trying to find, I don't know, security issues, and then they couldn't test with a real network, obviously. So they tested with SRS core network and something else, and they actually found issues. And then what do? It's like a pull request or?
No, so we have a vulnerability disclosure procedure. So we have a dedicated email address for disclosing vulnerabilities.
Look at that. They even have, good, that's very good. Happy to hear that. I know people who found issues in like networking devices or interface and whatnot, and they literally couldn't find a contact where to report the vulnerability, and that's a big problem.
So as you know, many of the vulnerabilities are not patched in the standard, because I mean 3GPP sometimes refuses to fix the vulnerability, right? What do you think about open sourcing the attacks?
Open sourcing what?
Attacks, exploitation. Open sourcing the exploitation for those vulnerabilities not patched by the standard. Refused to patch by the standard bodies.
I see.
I mean, if you want to develop like IDS or those kind of things, we need actually.
I see what you mean.
Packets.
So for many years, now less because I've been going less to conferences and whatnot, but for many years I would get a lot of people reaching out to me, contacting me, and I always say one thing. I get emails from a lot of people. I eventually reply, but from students, I usually try to reply as soon as possible. Anyways, I will get emails from a lot of people asking me for my code, for my IMSI catchers, all my exploits and whatnot, and I never share that. I mean, IMSI catching in LTE was literally a line of code in srsLTE, so it's not like I'm sharing that much code. Although I built a lot of things on top of it to make it look nice. But yeah, that's different. Use open sourcing exploits or open sourcing a modification of srsLTE that allows you to do something bad. There it's a bit more risky because now you're empowering all those like whatever people who you're essentially making it easy to do those bad things.
Yeah, but they say that they're not patching it because they don't think it is
Yeah,
important.
the standards are different.
Right.
The standards, patching a vulnerability standard is
Right.
it's
If it is
that
not
easy.
important, then it's okay to.
Yeah, no, I
process it.
hear you. I am myself frustrated with the standard. It's very complicated. It's on their defense, patching a vulnerability in the standard is not easy. Like patching the fact that you can like get names in the clear trivially and whatnot. It's not just like changing a line of code. Like these standards take many years for developing and what. So it's I don't know I don't think there's a good way yet to patch things on. They have like channels to revise vulnerability disclosure and whatnot. But I always wonder, what do they do with them? Because, you know, if you're a software company, you look at it, you validate it, and then you patch and you ship the patch. But on standards, like you cannot patch a standard. You just have to, like, you know, invite people, talk with them, be open to having those discussions and change things on the standards. And unfortunately, and this is very much my personal opinion, these standards have become so much of a political game that it's very hard to get like anything meaningful in terms of like security. Sometimes there's traction with some things, but some other things, like sometimes you just hit a wall. It's a good question. It's a tricky question. I don't have a good answer. Yeah, patching holes in standards, it's not easy. There's no good way of doing it. I have no idea what they do with the BRP reports they get, because there's nothing they can do with them. And not only it's difficult, but they sometimes are not very helpful in working with us to fix those things. I still personally would not release the code for things that I've done. I wrote a thing that you could like, somebody was asking earlier, can you map from RNTI to Teamsy? Yeah, you can do it. It's very easy. And I had it automated with a tool, and I never released any of those things.
Yeah, and there's a whole other discussion we could have about open source software as standard, I think. So thanks very much. Please thank our speaker.